Okay. Yeah, it's working. Hi, guys. Thanks for being here. I want to talk about writing your own monitoring plugins using the Linuxfabrik Python libraries. And let me say a few words about Linuxfabrik, who we are and what we do. Okay. For those who don't know us, who's on stage today, this is Navid Sassan. He's my right-hand man today and responsible for coding. And as this should be some kind of workshop, he do the heavy work and I'm the responsible for talking. And me, I'm Markus Frei, CEO and founder of Linuxfabrik. We are an open source IT service provider from beautiful Zurich, Switzerland. And what we do is we build your Linux and open source infrastructure and make it running smoothly, including Icinga as one of many open source applications in our portfolio. We are an Icinga premium partner since many years now, and the only one in Switzerland, by the way. And meanwhile, we are also known for our monitoring plugins and our Ansible framework called LFOps. You can find both and other projects on github.com/Linuxfabrik. Okay, let's talk about monitoring plugins. Remember, monitoring plugins are the building blocks of every monitoring, as we heard also yesterday. And but it's very hard to find plugins that are enterprise-grade, that are platform-independent, consistent, continuously maintained, that's also important, and cover the basics cover the basics as well as applications. So we wanted not only a good monitoring server, but also good working plugins to monitor our customers' infrastructures. Also, we wanted plugins that are, as you said, Alex, written from an IT service provider perspective. And we are operating 24/7, so supporting thousands of VMs, services, and applications in very diverse infrastructures and on-prem or in clouds. So hard to find good plugins for that, and that's why we have written over 200 plugins over the last years. Today, our plugins are widely used by many admins in data centers around the world. And so let's show you how to write your own monitoring plugin that will fit perfectly into this project. Let's say we want to write a plugin called MySQL Query that runs a warning and/or critical query against any MySQL or MariaDB schema, and the result, the number of items found or a specific number depending on the query, can be checked against a Nagios range expression. Okay, now how to do that? When it comes to parameter parsing, connecting to databases, fetching data, returning results, states and perf data, etc., we don't want to reinvent the wheel every time in every new check plugin. So let the Linuxfabrik libraries do the heavy work. And the new plugin, like all others that we have, just gets arguments, fetches data, and analyzes it. That should be the goal. So before we get started, we need to give you an overview of the Linuxfabrik Python libraries a little bit, or as we call them short, the libs. As of today, we provide these 35 libs listed here with round about 200 functions. And these libs help you write consistent and platform-independent plugins. All libs can be found on github.com/linuxfabrik/lib, well documented, and support PyDoc. Okay, normally, before you start coding, you should at least have a look at these libs listed here. And let me go through that. The base library provides very common everyday functions when writing Nagios plugins. Globals defines the global plugin states. Human converts raw numbers, times, and more to a human-readable representation. Shell communicates with the shell. Test provides test functions for unit tests. Time provides datetime functions. Text, obviously, is a collection of text functions. And URL, a very important library, helps you getting data by HTTPS, for example, HTML and JSON, whatever you like. Okay, next. And this is the list of libs we need for this presentation today. So even less, but plus a library called db-mysql. Okay, before we can start coding MySQL query, we need a working environment. And first of all, you normally have to clone the monitoring plugins and the libraries first. And after that, you create and activate a Python virtual environment. We call them here MP for monitoring plugins. And then install all third-party libs using pip install. Navid already did that on his laptop, on his environment. So we can go on. And now let's start coding. We want to create a first version that simply runs and does nothing for now. For that, we normally copy the example check plugin. You can find a plugin called example in our check plugin library, and then rename it. But here we start with a more minimal example. And Navid, could you please open the first version of the plugin? Yeah, great, thank you. Let me give you an overview. Let me go through that. Every plugin starts with the same header, defining the Python shebang, coding style, author, and so on. Then, after that, we define imports and constants in alphabetical order. Then we define the parameters in the parseArgs function. All plugins have at least -- version and -- always OK. And then after that, the main function. In the main function, the command line is parsed first. Should we scroll up a little bit? Yeah. Then data is fetched from outside, somehow. Then internal variables are initialized. Yes. And the data will be analyzed somehow after that. Then the output is built and returned. So, and there, and please scroll up a little bit, up to the end. And there we already used two library functions. The first one is OAO, over and out, from the base library. And over and out prints the plugin message. And if perf data is given, it attaches the performance data at the end and exit with a state given, or with state, always state OK, if always OK is set to true. That's the first one. And in the main function, we use CU also from the base library. Can you see that at the end in the? Yeah, thank you. We use CU, which always exits with state unknown, and optionally prints a status message and, for example, a stack trace if you have a runtime error, a sanitized stack trace if you have a runtime error in your plugin. Sanitized because of Icinga Web, for example. Sometimes you have special characters in your stack trace and that you don't see otherwise in your Icinga Web output. Okay. Navid, could you please go ahead and run that, just to give an impression how this looks like? Yeah, great, everything is okay. Perfect, we're finished. That's what we want to achieve. Okay. This was the first version. Now, we go on. Second incarnation, please open version 2. As I said, this is the second incarnation. Please scroll down a little bit. And that's what's changed. So that we can see that on top. Yeah. What we changed here. In description, we talk about what the plugin will do. This is important for every admin. If he tries to call the help function, we have to be clear about what this plugin is meant for. And after that, we set some constants used as default values for some of the plugin parameters. Okay, please scroll down. And we enhance the parseArgs function. After version and always OK, there we add new content to the plugin, new code. We add a bunch of parameters here. For example, we need a critical parameter. I have to look down here on this screen that I can see that. A critical parameter, the critical threshold. Then we add the critical query. That's the SQL query we want to provide. After that, we are dealing with a so-called defaults file. This is used to connect to the database. We want to connect to the database like all MySQL clients do, using a my.cnf file that you can put anywhere on your system, and to provide specific features like authenticating via a certificate, for example. That's done by a CNF file. And we need these two parameters for that. Then we have to deal with network timeouts. So we define that parameter and provide a default value. And after that, the same as we did for the criticals, we want a warning threshold and a separated warning query that we can run later on. Yeah. And these parameters are all needed for handling the database server, the queries, etc. And our tip is always look at existing plugins. Yeah, especially the other MySQL plugins and the plugin CSV values helped us here a lot. And this saves you time. And by the way, it's not unusual for parameter definitions to be more than half of the code of such a plugin. So don't wonder, that's OK, it's even good. So now, please, let's test the help function of the plugin. Yeah, works as expected. You get all the options we defined in the help function. Great. Next step, next version, next incarnation. Now it's time, actually it's time to connect to the database and do a first select. We also want to print out the first raw result. Okay, could you please open version 3? Yeah. And let's scroll down to things that changed. Okay, we need a new library to do that, to be able to connect to the database. This is, as I called it earlier, this is DB MySQL. And then let's scroll down. We have to import that library. We don't need new parameters. We already defined them. Just to give you an impression and that you can follow, we do it a little bit slowly here. Okay, and after we init our internal variables for message state and performance data, we define a new variable here called MySQL connection. And MySQL connection is actually a dictionary consisting of some attributes, defaults file, defaults group, and timeout. These are all values we provided via arguments. And all the arguments have also a default. And then after that, new library functions are called. 2 of them. The first one is COE, continue or exit. It's from the base library, and this function catches errors and exits on errors. So if you got any error from a complex error from a DB function here, for example, from a library, then you can always call COE, and then your plugin will exit if there's an error with a nice message with state unknown, or it will go on. And the second one, DB MySQL Connect, I don't need to explain that here because the name is clear. By the way, all DB functions, for example, we also have a DB SQLite library and so on. All DB functions are named exactly the same. So we always have a connect function in DB MySQL, DB SQLite, and so on. And the name tell what they do. And then after that, sorry, please scroll up. Yeah. Then after that, we also do that with check select privileges. So to check if we have select privileges. If not, we exit with an error. And otherwise, we go on and we fetch the first result from the warning query. OK. After that, we go to over and out. For now, we are happy. Could work. We just want to print the raw result to have an impression how it looks like. OK. Now, code for this stage is good and OK and finished. And if we want to test the plugin, and to be able to connect, we need to create a my.cnf file, which I told earlier is the best way to define credentials to access the database server. OK. Can you please? How it looks. OK. Yeah. This is how it looks like for his special use case. We have a user called MariaDB-admin. He has a quite simple password and the credentials to access the parameters to access the host and the port. OK. Now, everything in place. Let's test that version of the plugin by connecting to our Icinga DB and fetch the number of hosts in our Icinga DB host table. This is the command line call. So we use MySQL query. We provide the defaults file, the path to the defaults file called myCNF you saw. And then the warning query is select count asterisk from database Icinga DB table host. And then after that, we print the return code. And, OK, connecting to DB failed, error, and so on. And that's expected. This is the continue or exit function, printing what failed. And we can't connect currently because Navid has his database on a virtual machine. This virtual machine is only accessible via SSH, and we have to open up an SSH tunnel first to be able to access the port. So just to show you a use case. And now, if we run the plugin again, this is not going to error out. This is working. Yeah. And the select count statement returns 4 hosts in his Icinga DB host table. OK. Seems to work. Great. Let's go on. Now, from a technical point of view, the plugin more or less works already. So starting from here, it's all about enhancing the output and improving the code. And for example, let's move the code to fetch the data to a function. And let's implement the first use case that we get a single value from our database, from our query, meaning one row and one column, and check that value against the thresholds. Okay, let's have a look at version 4. And as always, let's scroll down to parts that changed. Nothing changed here. And as I demanded, okay, I just wanted a new function encapsulating the fetching of the tables. I call it getState and value, and it needs 4 parameters. I need the connection to the database, I need the query itself, the threshold that we should change against, and some sort of type. And if we have a look at the code, the interesting part is if we got a query in line 117, if we got a query, we do the MySQL select. If it's error out, then we have to exit. If we got a result and we implement the first use case here, we have a simple count query, then we got one value. And if we have a warning query provided, then let's get the state, if it's okay or not. And this is done by the getState function from the base library. The getState function returns the state by comparing the value, the first parameter, to the given thresholds, the second and the third parameter, by a comparison operator. And the default comparison operator is greater or equal. Warning crit may also be none. Okay. And then after that, we return state and value. And of course, we have to call that function in the main part here, where we analyze the data. We call getState and value. We need 2 variables for the result. And after that, we compare the state we got with the current state of the plugin by using the getWorst function, also from the base library. And getWorst compares 2 states, state 1 and 2 state 1 and state 2, and returns the result based on the value, the most worst result. So if you got a state OK and a state warning is returned. If you got state warning and state critical is returned. You can see that there. Yeah, the same then for the critical query. And after that, we have the final state of the plugin. And we are nice. We close the connection by using the db MySQL close function. Closing the connection is important. It not only frees up resources, but it prevents ugly entries in your log file, aborting connection, and so on. So please close everything and clean up if you're done with your work as early as possible. Now, that's it for the moment, I would say. But nothing to test for now. Let's go on. Okay, because, of course, depending on the query, we might also get a list, and so more than one row. And how to deal with that? Like the query on this slide, select name and address from icingad.db.host. For example, where we now fetch name and address. In this case, let's count the rows we got. And so and for now, also let's implement Nagios ranges. For this, we already have everything we need in the code. And for those of you who forgot about Nagios ranges, the syntax, like me, every time, I provided 2 examples on this slide. The first one looks normal, but under the hood, it's also a Nagios range, and alerts if you get more than 20 hosts back. And the second query and the second Nagios range alerts if you get less than 20 hosts back by simply adding the colon. OK, now please open version 5. And let's get through the code here. Let's see what Navid coded in the meantime. How to implement Nagios ranges and how to implement if we get a result set instead of a single value. Obviously, to achieve that, we have to enhance the function here. And the changes are highlighted here. If we got a result and the length of the result, the number of rows is 1 and the number of columns is 1, then obviously we have a single value as before. But now we also want to return the length of the result. OK, that is done there. And when we scroll down, then we introduce Nagios ranges by simply providing a new parameter to the getState function called operator. It's an optional parameter, as I told earlier before. Per default, it's working with greater or equal operator. If we provide range, then the value is checked against the thresholds using Nagios syntax. And that's all. Nothing new and fancy here. By simply adding 2 parameters, we have Nagios range capability. It not always makes sense to introduce Nagios ranges, so this is not the default, but yeah, for this, it pretty much makes sense. Do we have something at the bottom? I think that's it.
That's it.
That's it? Yeah? Mm-hmm. OK. Yeah, then we are done for that. So let's go ahead and do the next iteration, version 6. OK, we haven't worked on the output yet, so obviously we need to do that. And we want the output to be shown as shown on this slide. I want a string. I want 20 results from my warning query, and then in backticks, so markdown, the warning query, for example, and if the query has triggered an alarm or not. So always feel free to use markdown in your output. That's not an issue. Icinga Web displays that in some cases, so that's nice. Use markdown. And let's have a look at the version 6 of the plugin. OK, to handle output, we need a new library. And this is the text library. The text library offers some very nice functions. We import it here. Then let's scroll down. Nothing changed with the parameters. They stay the same. GetState and value also didn't change. But the main function has to be enhanced because, yeah, after analyzing the data, we want to print it out. And that's where we work on the build message block. OK, what we do here is, if we get a warning query by the admin, then we want to define that message. Message equals to the string, providing some variables. And the important thing here is, what I want to point out is the pluralize function from the text library. Pluralize returns a plural suffix for a noun depending on its value. Imagine I don't want to print 1 results and 20 results, as most of the plugins do. I like it the correct way. I want to print 1 result versus 20 results. And this is what pluralize do. It's pretty cool. And we also need to print out the state in clear text. If we got an OK state for testing the value against the threshold, then we don't need to print anything. OK is OK. But I want to print out if we got a state 1, then I want to print out warning. If I got state 2, I want to print out critical. And this is what state to string does. It returns the state string representation from the base library. OK, and then the same for the critical query. And if we have one and we have a message, and we both join them together by an AND if we have both, if both have been provided. And that's it. After that, message is defined. And yeah, it looks good. And now let's have a look at the command line call. It's time to test the plugin using a real-world scenario. I have the default file, mylcnf, a warning query. And let's say, to keep it simple, imagine you only run RHEL 8 hosts and compatible in your infrastructure, OK? And you want to get a warning if there are more than 16 hosts in your Icinga DB hosts table, and you want to get a critical if there are more than 20 hosts in your table. Because if you get a critical, then you can call us with joy, and we can sell you an Icinga subscription. So that's great. Navid, please run this query to see the plugin in action. OK, as expected, he's the lucky guy. He only has 4 RHEL hosts. And you see the output, 4 results from warning query, and state is OK. Obviously, we need to do some more work on the output, but for now, a quick side note. Many library functions, like pluralize in our libraries, are pretty cool and can do much more. If you have a look at this slide, pluralize can also handle some special cases, for example. What I did here is I import the lib text, then I define a simple function that just does printing, and depending on the count of, or depending on the value of count, some magic happens. For example, I can use pluralize to define the output 1 certificate is expiring, or 2 certificates are expiring, by simply using pluralize this way. This function is heavily inspired by the Django MVC framework, so it's bulletproofed. The text library, by the way, is also, it's just English only, of course, and we don't support other languages. OK. The next step. Plugin output, yeah, looks nice. But if we get a list, I want to see the result set. So I want to print the result set using an ASCII table. But I want to shorten it if it's too long. Imagine we get thousands of hosts here, thousands of lines, and as an admin, I just want to get an idea about the data and to just get a quick overview. And because on an alert, I have to deep dive into the application, into the database, and look at the application anyway. So I just want to get a quick overview of the data. And I want the new table appended after the first line of output. What we've seen earlier, after the first line of output, it's appended. And we've done that in version 7 of the plugin. So Navid, please show this. version. And let's see how to do that. Let's scroll through that plugin. How to add a table, how to create an ASCII table. Okay, yeah. This is done in the get state and value function. We have to have an indicator if data has been shortened or not. This is shortened equals false. We assume, okay, we return all data. And then later on, if we got more than one row, in this case, we shorten the result if there are too many rows. And we do that by, in this example, by hard coding the limit. If we got more than 10 rows back, then we shorten the result by simply striping the array into the first 5 results and joining them with the last 5 results and setting the shortened indicator to true. And of course, we return the result, the shortened result set, and the shortened indicator at the end. So now we have to fine-tune the function call in the main function where analyze data happens. Yeah, there the 2 new parameters are or result variables are added, and then later on we want to create the table after the first message we already have. Okay. Okay, this is the code for that. If we have a shortened warn, if the warning table result set is shortened, then we print an attention. Attention, dear admin, we have shortened the results, just for your information. And to create an ASCII table, we use the getTable function from the base library. We provide the result set. We provide the keys where to look up the data, and which headers have to be printed on the ASCII table in the first line. And yeah, this obviously takes a list of dictionaries, formats the data, and returns the formatted data as an ASCII table. We do this for the warning result set as well as for the critical result set. And that's it. And this is appended to the message. So we have a multi-line message. And yeah, I would say please run the plugin and let's show how it looks like. Okay. This is the result. We have 2 tables here. We have a warning query, a critical query selecting for name and address. And as you can see here, the plugin looks up the keys, its name and address, prints that in the first row, and with the results. For obviously, both queries are identical, so we got identical results here. Okay, we are nearly finished with this plugin. Now let's check user input, for example, and show you how to add performance data. Let's have a look at version 8. And let's scroll down. How to check for some user input, where, and how to add performance data. Nothing changed here, that's good. Okay, here we go. Main function, after the argument parsing, we immediately check user data. If we got no warning query or no critical query, the plugin simply makes no sense. So we call CU, which always exits with state unknown. The plugin doesn't know what to do, and prints a nice message, nothing to check, no queries provided. Please run again, so to say. And then later on, how to add the performance data. We would just want to, for example, return the number of rows. Let's scroll down. Yeah. before printing the final message, we attach or return performance data by using the getPerfData function from the base library. It takes a bunch of parameters. It needs a label. It needs the current value. It needs a unit of measurement. Is it bytes? Is it kilobyte? Is it seconds, milliseconds, and so on? A warning, it could at a warning threshold, a critical threshold, or the min and max values. So it returns a string formatted according to the Nagios plugin standard. And perfdata, performance data, is added at the end of the output by attaching a pipe symbol, and yeah, that's it. That's pretty much it. We simply return the number of warns and critical rows we got back. Okay, please run the plugin one last time. Yeah, and as you can see there, performance data is added. So we are finished. Plugin works as expected, I would say. So what we did so far, to summarize, the plugin looks really pretty good and works like a charm. It's not that heavy to write that. We wrote a plugin that does one thing and does it well. That's very important. It's a platform-independent plugin because it's in Python. It also runs on Windows, on Proton OS, on every OS where Python can be run. And if you want to compile it for Windows, for example, we have a CI/CD pipeline where when we provide a .windows file, then the CI/CD pipeline knows what to do and compiles it with NuIDCA on a Windows machine. The plugin supports atomic monitoring because it does one job. And it's fast, reliable, and uses few system resources as possible due to the libraries. It reports briefly and precisely, and also provides information for troubleshooting, what we've seen in the first slides. But a main advantage is it can also be used universally, and due to the unlicense, it is dedicated to the public domain. Okay, but we are not finished yet, because that was only the first half. I want to torture you a little more. To be production ready, a plugin needs at least, to be checked by Pylint. Pylint, I will show that in action. The plugin needs an icon for the web interface. We need a useful README file. An Icinga Director basket configuration file would be very nice. All our customers also run Icinga Director. Optional with an Icinga service set definition. And changes that we made to the plugins have to be mentioned in the changelog. Okay, when we come to Pylint, Pylint helps you check the code and its quality, detect programming errors in the Python language, and offer simple refactoring suggestions. Could you please show the output of Pylint MySQL query for the last one? Yeah. Okay. We got some results. But this is how it looks like. You have to get used to it, but be careful, not every line is actually a finding. You have to interpret the lines. Some might even be wrong, but there's still room for improvement for our plugin. So normally we would try to reduce this result set. The next thing, icons. Icons are needed for the web front end of your favorite monitoring system. Could also be Nagios or whatever. And in this case, we can reuse an icon from other MySQL plugins that we already have. So that perfectly fits. And this is what it looks like on an Icinga DB web interface. Now let's talk about the README. Every plugin needs a detailed README. What sucks is if you got a plugin and it's not documented. You don't know how to deal with the data. You don't know how to interpret the results and so on. So it is at least as important as the code. Each README in our project, each README has the same structure. So write the README so that an admin without programming knowledge can use the plugin and knows what to do with the results, please. The README should also point out any special features or issues and explain any how and why. And writing the README could take as long as writing the plugin itself. And often we start writing the README before we start coding, so that we know what to expect and how to write the plugin. For the structure, use the README provided by the example plugin, or use any other README in the project, an existing README as a starting point. In our case, for this README, we used CSV values, the README from CSV values. And first, fill in the title, the check name, and the overview, as seen here. Okay, after that, after the overview, we demand a fact sheet section. Provide the fact sheet which talks about check interval recommendations, here every 5 minutes, special requirements for the plugin, or which Python libraries are needed if running the plugin from source code, or if you want to compile it. Then you need to know which third-party Python modules or any requirements you have to fulfill. Next is the help section. And there it's easy. Please print the complete output of the plugin's help function with 80 characters maximum line length. By the way, for this we already have a tool in our tools directory in the plugin project which does that for you. It goes through every README and updates the help section by calling each plugin with the help parameter. Yeah, the next section, usage examples. There, please give some common examples. Usage examples show some extended command line calls and its corresponding output. In the state section, after that, explain what state is returned under what circumstances. You can see that here, one if number of rows or single value is outside any range, for example. Otherwise, okay. Then after, in the perf data section, provide a table describing all the performance data items, their names, their type, what they do, what they are meant for. And optionally, after that, if it's a complex plugin, optionally provide a troubleshooting section. Okay. README is done. Next thing, Icinga Director basket configuration. You can't create or define a Icinga Director basket from hand. It's a JSON file. Instead, we define a YAML file. Create this YAML file. There we define, for example, a higher timeout. A higher default plugin timeout here. Plugin timeout is normally 10 seconds. Here we define 30 seconds timeout because some queries might take longer than 10 seconds. We define a new check interval, 300 seconds per default for the Icinga Director service template later on. And we tell Icinga Director, please take care of performance data. We return performance data. And now, our tool, check to basket, here at the bottom, the check to basket, this tool creates the Icinga Director basket configuration. Could you please show this, how it feels and how it looks like? Yeah. We call check to basket, provided the parameter for the plugin file, and then this tool creates everything we need as a JSON file compatible for Icinga Director. And the result is more or less 500 lines, 502 lines of YAML code, including UUIDs for every object it needed in the Icinga Director. For example, the data fields, you can see that there. Data fields, command, service template, and so on. So you check in the YAML file, and later on, tools are doing the rest. We are not done yet. There's more to do, but let's skip for now. Normally, you would define a unit test, at least one. But these are nearly impossible for this type of plugin because you need a database, you need some tables, and so on. So nearly impossible. We don't do that today. We also don't need to enhance the Python requirements TXT, as we didn't introduce new dependencies to any third-party library. All sudoers files we provide in this project are fine, don't need to be touched, and we won't define a Grafana dashboard for now. So yeah, let's go ahead and give you a demonstration to see the plugin on action on an Icinga server. First, we need to create a complete Icinga Director basket configuration. As we did earlier, this was the basket configuration for the plugin, and we want to join all plugin basket configurations together using basket join. Tools basket join creates a complete Icinga Director basket. Then we have to import this result into the Icinga Director. For this, Navid copies the complete basket JSON to his virtual machine. Into his temp folder, he switches to his virtual machine. And then he used the Icinga CLI Director Basket Restore to import that JSON file into the Icinga Director. Yeah, and Navid, please go ahead. Yeah, switch to Icinga Director. And let's deploy the changes. And I would say now let's create a single service using our new plugin. And let's do the same queries we did on the command line. Let's name it Icinga host, that's good. Let's use the MySQL query template. That's what the tools have created. Let's do that on his own host. And there we have all the parameters we defined in the plugin using argparse in Python.
Including the descriptions from the plugin that we defined. So you know what you're doing in the web GUI as well.
All help texts are there, yeah. And as I told you, if you get a warning or critical, then please call us for any Icinga subscriptions. Deploy that. And let's have a look at your host. Yeah, that's how it looks like in Icinga. Of course, we haven't deployed the Icinga icon or the icon for Icinga Web, but that's not that important. You see the plugin output for results, the two tables for the two queries, and the performance data. So everything works as expected. I would say we are done. That will conclude the practices for this topic. And you'll find us on linuxfabrik.ch. The sources of all monitoring plugins and the libs are located, as I told, on github.com/Linuxfabrik, where you also find the contributing file if you want to know more about how to write plugins and what to keep an eye on. So please donate, spread the word. We are always happy about feedback, about pull requests, issues whatsoever. And if you use the monitoring plugins, then please tell the world at Show and Tell on GitHub. And on exchange.icinga.com, the Linuxfabrik Monitoring Plugins project is the most viewed and most downloaded project up to now. But please also write a review there. We just have one review. And if you like the project, please consider sponsoring by GitHub sponsors, by PayPal, or even better, by concluding a service contract and getting professional Linux support. So no matter what, please star this project on GitHub and spread the word. Yeah, thank you for taking the time.
So thank you very much, Markus and Navid. Are there any questions? We are a little bit ahead of, let's say, we are half an hour ahead of time. Anyway, we have time for questions or conversations.
I was wondering which library you use in order to present the tables. Is it Pandas or?
To present the tables?
You build the table in the output.
Yeah, it's a self-written function. Yeah.
Okay. Is it available?
Yeah, the libraries are for free available on GitHub.
Okay, thank you.
Yeah.
Any other question?
Is it safe?
So we still have half an hour to spend the time together, so I don't know.
What's a quick one?
Lunch is not ready yet. Anyway,
then it's time for a break.
If we're done and run, it's time for a break. Means you are still around. So if you would like to ask questions or have ideas, just get in touch with each other. And with that, I will say I send you to a to an early lunch break. Food will be ready, I think, around 1 p.m. That's the plan to be. So enjoy the sun outside.
Time to grab a coffee.
Grab a coffee, have a discussion going here. Thank you very much for the efforts and for the wonderful workshop.
Yeah,
Thank you.
Pleasure. Thank you.
Thank you.